We will finish the last part of our section in chapter 2. But before we start on this, let's recall the terms that we discussed in chapter 2. What do we still remember? What was our main objective in chapter 2? Main objective to solve. Okay. I was like, to solve differential equation. Which type of differential equation? Which order? First order. What's one method that we use to solve it? Other than I would say now, yes,
Linear equation.
we solve linear equation. Do you still remember how to solve usually linear equation? What do we need? Okay, first, the method of solution, we need to write it first in what? Standard. How do we write usually in standard formulas? I'm not, okay, yes. How do we write in standard form? Yes. So what do we need? Divide by what we have before y prime, provided that it's not equal to 0, right? Okay. Then what do we need? Sign. Sign. For the linear equation, Amro was saying that first we need to make it in standard form. After the standard form, there is something that we do. What do we find? Integrating factor, which is e power p dx. Do we put constant to the integrating factor, miss?
No.
Why? Because we are finding an integrating factor and not all integrating factor. We care about finding one, so we choose the easiest when the constant is what is. After the linear, before the linear, there's something easier, right? What did we learn on?
We determine if there's a homogeneous solution.
You meant after, okay. Homogeneous equation. When can we say that an equation is homogeneous? It should be written as mdx plus ndy, right? Okay. And to be homogeneous, each of these functions, it should be what? Homogeneous of the same degree. Ahmad, what's the method that we usually use in this case if it's homogeneous? We use, do you remember substitution, right? Which substitution do we use, Smith? We use y equal ux. And dy, do we keep it the same? We write it as udx plus x du. The new equation, it will be in terms of u and x, and it should be one less. We'll simplify it to get it separable, right? Then we'll solve it as u, and finally, when we find the implicit solution, instead of u, what do we put? Y over x. Other methods that we learn, they are the exact, right? So how do we determine whether a certain differential equation is exact or not? What do we need to find? Y and if they are equal, then it's exact, right?
Yes.
And if they are not equal, it means that it's not exact. Sometimes the differential equation is not exact. We will check through a certain integrating factor if we are able to transform it to exact. Okay? So these are the things that we covered. Last lecture, we said that our topic is solution by substitution. The main objectives, they were to solve homogeneous ordinary differential equation, and this one we were done with it by transforming this one using substitution to separate one. For today, we need to cover this objective. Okay, miss? First, we'll start with the form of Bernoulli's equation. Is anything regarding this differential equation? So this differential equation, we can write it as y prime plus p of x y equal f of x y power. Is there anything special here? Doesn't it look like something?
Looks like standard form.
Standard form of what? Linear equation. But why isn't it linear? Where's our problem?
Yes.
The px for this one. So the linear, if we go back to the linear, what's the shape? Linear first order, it is y prime plus p of x, y equal to f of x. What's the only thing that is here that changes here? This one is, it is the non-linear form. We need to solve this differential equation, and the method that we will use is substitution. But which substitution here? We will use u equal y power 1 minus x. And it will be given like, and y, it may be given y squared, so and this 2. It may be given y power 4, so and this 4, and so on. So we need to use the substitution of equals and the new equation, it will be, instead of y, what should we find? We should find u. We will solve the u and then we will get back to the y. Okay, miss. Can we just, instead of y, put this value of u and y prime, we keep it the same? What do we need also opposite to change the y prime? Miss, here each question, it will have its own substitution based on the n that is given. Okay, miss? Please write your notes. We'll start with an example, and then I will choose for you an example from the practice exercises to do it in pairs and then discuss. Did you finish writing? Okay, what do you think? When we use substitution, we will change the differential equation into a simpler differential equation in terms of solving it. Which method should we use? Where's our main problem in this one? Or because of that, we are unable to solve which one? So basically, we will transform it to one. Okay, and the linear value we solve it, as your colleague was saying, we will use the integrating factor to solve. Okay, miss? What we need to do now is to solve this differential equation. Okay, just write the differential equation and we will solve it. Did you write the question? Okay. How do we solve this? In the method of solution, we will start as u equal y of power 1 minus x. Then write, after that, write y in terms of, so this is step number 1 and this is step number 2. What do you mean by write y in terms of u? If you are saying u equal y squared, so y is equal to radical u. Okay. If you are saying u equal 1 over y, then y is equal 1 over u. We know how to write it, change it. Okay. And the third step, already you have dy by dx, right? You will write it as dy. You need to change it to du, right? So dy by du and du by dx. This one, are we able to get it, miss? Y is in terms of what, miss? U. Are we able to get this one? We will get. Then the fourth step, substitute y and dy by dx in the ODE. What should we get now? Our ODE will be transformed into simplified, and we get what? Which type of ODE is that? We will get linear ODE, then solve the linear. Okay, miss, this is the method of solution. Now, the thing that is easy here is that we don't. Now at this exercise, we wrote the exercise. What's the first step? Right, the standard. So let's copy the question again. X dy by dx or y prime is the same plus y equal x squared y squared. We will divide by x not equal to 0. What will we get now, miss?
dy is
Dy by dx plus 1 over x. Y equal x y. This one is what? Okay. The first step. Are you okay with it, miss? Then what will be our substitution now? U equal y 1 minus n, which is y minus 2, y power negative 1, which is 1 over y. Do we agree? Okay. We wrote u in terms of y. Go back to what you to your course notes, miss. In the course notes, what did we write, miss? Write y in terms of u now. Writing y in terms of u, find y prime. So the second step, what do we need to do, miss? Write u equals 1 over y. It means that y is equal 1 over u. Right, miss? Third step. We said that we need to write dy by dx equal. This is achieved with du dy by du. Y equal 1 for u. What's y prime? Minus 1 over u squared, right, miss? Substitute now in the formula. We substitute now in the formula. What will we get, miss? dy by dx. Instead of it, what will we put, miss? Minus 1 over u squared, and here du by dx. Or if you want, miss, y equal 1 over u, derivative is minus u prime over u squared. You can do it. Okay, miss? These steps, are you okay with that? Johnny? Muhammad? Luay, is it okay? What I need from each of you now to do substitute. So again, what are we using? We wrote this steps, right? The first step we did it, the second step we did it, the third step we did it. Now what do we need to have? The fourth step, substitute. So please substitute, miss, in the differential equation. Okay, so what was the differential equation that we have, miss? So give me the differential equation. What the standard form for it? We need to substitute where? And it was dy by dx, right? Plus 1 over x, y equal x, y squared. So dy by dx, we will put instead of it minus 1 over u squared du by dx. Is it okay, miss? Plus 1 over xy, what was y? 1 over u, and here x, y is 1 over u, y squared is 1 over u squared. This step, are we okay with it? Are we okay with this step, miss? Let's click down. What do we have here? Okay, we need to have here only du by dx. So we should multiply the whole one, multiply exactly by negative u squared, the whole equation. Please multiply the whole equation by negative u squared. What will we get now after we multiply? So we will get du by dx. 1 over x, it stays the same, right? We multiply by negative. It means that negative 1 over x. But we have 1 over u and multiplied it by u squared. We will get. We multiply by u squared. Means 1 over u multiplied by u squared. U squared over u. U, not u cube, right? Okay. Over u squared times negative u squared. X over u squared times negative u squared. Negative x. Now look at this equation. What's the type of it? What's the type of this equation, Miss? First order linear. So we transform a non-linear to what? To linear. First order linear. Or what's determine now your P and determine your A. Is it standard form? Yes. Okay. So determine your P, determine your A, go to your course notes and try to solve this linear one. Each together solve it. Okay, so what will be that now? What's our P? Our P is? What's our new P, Miss? Minus 1 over x. Our A? Minus x. What's our integrating factor? So integrating factor is equal e power P dx and e power minus dx over x, e power minus ln x, which is perfect. So this one will be our integrating factor and we'll put it in a box. Then u times the integrating factor is equal integrating factor times a dx, right? We will use this one. Okay, u times the integrating factor, it means that 1 over x times u is 1 over x, what was x? Minus x dx. So 1 over x, u equal minus dx, u over x is minus x plus. So what's u? How do we get u? U is equal minus x squared plus dx. Can we consider this one as our final answer, miss? Okay, y side,
Because C equals 1 over 1.
we need y, right? So u, y is what was 1 over u, right? So now y equal 1 over u. Do we have u? What's our u, miss? Now this one, can we consider it as our final answer? Okay, because we want to solve for y. If you want to write this one, and then I will. Okay, what we will do after this one is that we will go to the slide of method of solution, just for those who weren't here to take a photo of it. Then what we will do is that we will solve. I will give you time to solve an example. During this time, I will take attendance. Okay. So this one is our final answer. Any questions, miss?
If you go back to the slide number 23.
23.
Yes. Yeah, and the second step, when it's 1 by x, and when it to be substituted, equals to.
We substituted it. First step. This one in this way. Now we are breaking it into parts, into steps. So here u equal. Here what did we do? We substituted. We substituted. Do we have any questions so far? Okay, let's choose an example here to solve that. So, okay, would you like to solve something in e power x? This one is y squared. I prefer not to use y squared again because already we used it. Miss, this one is y power minus 2. Would you like to try the minus? Let's try this one. I will zoom in. So this one, how can we write it, miss? Y power negative 2. So here n is negative 2. When you put y, u equal y power 1 minus n, pay attention to the minus and minus. And write it in standard form. Let's start with n. We will not solve it on the board. We will just discuss it. So each two together solve it. Abdullah, check with your colleagues because they wrote the steps.
The name of the
Very
Well, maybe about the.
Yes. Or section is 2, right? أحمد عبده is here, Noor is not here, Abdelaziz is here, Abdulrahman is here, Muayyad here, Luqayd here, Sultan is here, Abdullah is here, Dilshad is here, Ismail here, Abu Sayyid, Amro, Johnny, Ali, and Ahmed. Thomas, how did we start? U equal y power 1 minus. So U is equal y3, right? Then y is equal to U power 1/3, right, miss? Okay, U equal y power, y equal U power 1/3. It means that y prime is 1/3 U power minus 2/3 U prime. And now you can substitute. After substituting, remember that we need to multiply by everything below U prime. Before U prime. Can I? Okay, we're done with chapter 2. Now, what's left in the first part of the course is we already have section 1.3 to do it as project. I was planning to have it today with discussion and along as with something, but I found that some of you don't have their laptops. So please, next lecture, bring your laptops with you. And because we will also link it to section 3.1. Okay, miss? So next lecture, we will discuss and link it together, in groups together, they will link it to section 3.1. So now we are done with the first part with first order. The next step is we need to move higher order, right? So we need to talk about second, third, and other. And these ones, they will be covered in chapter 4. In order to understand the section, what we need is some basic derivatives formulas, basic integration formulas, and we need the determinant from linear algebra, but it's okay if we got the determinant or we did not take it before, I will be explaining later. Our main objectives for today is to demonstrate understanding about boundary value problem. So we talked about initial value problem, right? Now boundary, we will talk about that. Demonstrate understanding about fundamental set of solution and apply row reduction of order to find a second solution for a second order differential equation. We will start first by finding the difference between initial value problem and boundary value problem. Do you still remember initial value problem? Let's say if we have a first order differential equation, what should we have? How many initial values? If we have second, 2. When we were solving second order and we gave the initial value, we said, let's say y1 equals 0, y prime also of what? 1. So we are using the same value that we use for y, we use it also for y prime. In boundary value problems, this doesn't care. They will be different. Then we'll talk about homogeneous equations. We are talking about homogeneous, not first order differential equation. That is M and N are homogeneous here. Homogeneous differential equation in another way. We'll talk about the general solution, the Wronskian, which is related to the determinant. Then we'll discuss the non-homogeneous equation, general solution, and then we'll talk about reduction of order. So this part that we will introduce today is an introductory for solving. At this moment, Miss, it doesn't mean that I will teach you at this moment you have a second order how to solve it. We will just understand solution for it. What does it mean? Fundamental set of solutions for it. What does it mean? Boundary value problem and reduction order. Okay, Miss? Initial value problem. We still remember it. Look at it, Miss. What do we have here? Same one. We are evaluating these y's, y prime, y double prime, all of them at the same what? Value. So if I'm giving you y0 equals something, we should give you y prime, y double prime, y triple prime, all of them at which value? As. Okay, Miss? So this is an initial value problem. We talked before the existence of unique solution for which value problem? Initial value problem, first order, right? Here we are considering nth order. So if it has this shape, it means that it's linear. Again, look at it. It's related to what, Miss? The continuity. So if the coefficients of y, y prime, y double prime, and so on, along with what's after the equal, they are continuous. And of course, a and x shouldn't be equal to 0. And this initial value problem, it will have a solution, and the solution is what? Unique. Okay, Miss? What do we mean by continuous? Suppose that g of x is equal 1 over x, and I'm giving you the initial condition at 0. It's not continuous at 0, so I cannot like deduce if it's correct or not. Okay, Miss? As an example, look at this one, Miss. This is, what's the order of it? Third order. How many initial conditions? 3. All of them at same point, right? Okay. What do we have before y triple prime? Is it continuous?
Yes.
Constant. 5 minus 1, 7, 0. Do we have problem in that? So what can we say about this one? What does it have? Unique solution. Okay, Miss? Let's look also at this one. What do we have before y double prime? So do we have any problems? Any problems in 12x? Continuous or not? Continuous. Okay, what can we deduce? What does it have? Unique solution. Okay, Miss? Any questions? Okay, try this one, Miss. Do we have any problems in the coefficients, Miss, or after the equal? E power x, does it have any problems? This is sin x times y. Sin x, do we have any problems for it? Y cube, x cube. So what can we deduce? Unique solution. This is regarding initial value problem. What do you think about boundary value problem? Does it have any unique solution? We will consider the same equations, but we will get the same differential equation, but instead of having initial value problem, we'll put boundary value problems, and we will check if we will still have unique solution. Okay, miss? Again, during this lecture, we will not learn how to solve the differential equation. We want to understand initial value problem uniqueness. We need to understand boundary value problems and whether they are always unique. And then we will talk about fundamental set of solution, which is linked to the determinant. Any question? By boundary value problem, we'll consider at this moment only second order boundary value problem. So we have this shape. Boundary means, you know, from the name boundary, we have a differential equation. It's valid when x is between a and b. So are the boundaries a and b boundaries. Okay. So the boundaries, they are giving us ya equals something and yb equal to something. What do we call these ones? Boundary values. Okay, miss, for the boundary condition. Please write it down and we will check now. Okay. Did we write the boundary value problems? We will give examples. We'll give an example when a boundary value problem doesn't have a solution. It's when it has more than one solution, or when it has like more than one solution, and when it has no solution. Okay. Let's look at this example. W prime plus 16x. We know that this one is a solution for it. How do we know that this one is a solution of the ODE? We substitute, we get the left equal to 0. So the solution is what is given. Okay, just write these ones. The first boundary value problem that they are giving us is this one. So we will copy it now. X double prime plus 16x equals 0. They are giving us the solution as d1 sine 40 plus d2 sine 40. This one is what, miss? Okay. The boundary condition are x0 equals 0 and x5 2 equal to 0. Our aim is to find the solution. When we say find the solution, it means that find C1 and C2. Can we start? How do we find C1 and C2, miss? Where should we substitute? As we did in the initial value problem, our aim is to find C1 and C2. We have x0 equals 0. So instead of t, we will put 0. X, it should be 0. We will get an equation and then an equation in the other one. Can we start with this one? So 0 equal 0. What does it mean? T1 cosine 0 plus T2 sine 0 equal to 0. Right, guys? Right? Pi over 2 equals 0. What does it mean, Nancy? T1 cosine 4 pi over 2 plus T2 sine 4 pi over 2 is equal to 0. From where did we get these ones, Miss? These are given. We are substituting. Is it okay, Miss? Ahmad? Muayyad? Here, guys, are you okay with it? Again, next lecture, please bring with you your laptops. Bring with you your laptops. Or at least each group bring one laptop. Okay, let's rewrite the equation. What's cosine 0, Miss? Cosine 0 is equal cosine 2 pi equal to 1, and sine 0 equal cosine 2 pi equal 0. Substitute here and give me the new equations. Again, our aim is to find what, Miss? C1 and C2. So what will we get? C1 cosine 0, C1 equal to 0. Second one, C1 plus C2 0 equal to 0. So what did we get from the two equations? C1 equal to 0. How many equations do we have? Two equations. How many unknowns? But when we were solving, we got only one. C1. Did we get C2? What does this one mean? It means that y equal 0 times cosine 40 plus T2 times sine 40. So y is equal to T2 sine 40. It means that this is a solution for every value of C2, right? Right, Miss? So how many solutions did we get? Unique. Infinite solution. So this boundary, if it was initial value problem, we should get unique solution. Here, as a boundary value problem, what did we get, Miss? Infinite solutions. Why, Miss? Because whatever the value of C2 is, it will be again a solution. If you want, try 2 sine 40 and 3 sine 40, both of them, they are solution and satisfy the boundary. Please write it down. Go again through the steps. If you have questions, let me know. Cosine 4 pi over 2. Yes. Sine 4 pi over 2 is 0.
I need to do the last step.
Yeah, so C1, I'm just writing it in this way. We are writing it in a better form.
I thought it's going to get the solution.
Yeah.
No, so.
We simplified it. Oh, okay. Make sure that we understood it. We will give other boundaries and we will check if we'll get the same answer. We'll get again to the function. So try the same equation, the same solution for it, but try x of 0 equals 0. Please write x of 0 equals 0 and x of pi over 2 equal 1. So write the same one, x of 0 equals 0 and x5 of 2 is equal to 1. Still we have the same solution in terms of C1 and C2. It's just we need to find C1 and C2 if they exist. طب مؤيد. The next one that we will solve, let's try this one. So again, step the prime plug in x equal to 0, x equals C1 sine 14 plus C2 sine 14 is the general solution of the ODE. What we need to do this is solve the boundary value problem. Set the prime plus 16 as equal to 0, subject to the boundary condition x of 0 equal to 0, x 5 to 2 equal to 1. So please do this one. Did you stop?
C1 and C2.
C1 and 0 and C2 is one, yeah, we will try it together. This sine phi is 0. Sine phi is 0. And sine phi is negative 1. You use this one. What did we get here? An answer?
Two answers for C1. C1 will be two answers.
Okay, let's check together. So, B equal to 0, what does it mean? And x of 5 over 2 equal 1, what does it mean? X of 0 equal 0, it means that C1 sine 0 plus C2 sine 0 equal to 0. And this one, C1 sine 5 over 2 plus C and C1 cosine 4 pi over 2, right? Plus C2 sine 4 pi over 2 is equal to 1, right, class? Yes. Pi over 2, yes, but you have 4. Okay. So what will we get now, man? C1 times 1 plus C2 times 0 equal to 0. From where did I get 1 and 0? Cosine 0 is, and sine 0. Okay. Now, C1 cosine 2 pi is 1 plus C2 sine 2 pi is 0. We will get 1. Miss solving this one. We got C1 equals 0 and C1 equal 1. Is it possible? Can we have 0 as a value for C1 and also 1 as a value for C1? So this one is what? Impossible. What do you mean by impossible, Miss? Do we have, does this boundary value problem have a solution? Had no solution. So till now, we gave an example when it has infinite solution and when it has no solution. But does it mean that either it has this or that? We can have a solution for it. We can have some examples where a boundary value problem has a solution. Would you like to try one of them, Miss, when it has a solution? I prefer that we try because this one, not all of us did it. So please write it down. We will write again the same boundary value, the same differential equation, and we'll change the boundary value. Like this lecture, it doesn't depend on the previous lecture, so we should be able to understand this, okay? For those who finished writing, I will go back to the slide, but for them finished writing, we need this one. Already the solution is given. The general solution for the ODE is given. We need to try these boundary values. X0 equals 0 and x5 over 8 is equal. X5 over 8 is equal to 1. So x0 equals 0 and x5 over 8 equal 1. Please try it. You can try it each two together while your colleagues are writing. Yes? 5 over 8 equal 1. This again, hopefully next week we will do more. Hopefully next week we will do our discussion and we will continue the part of the project in class in which we will link it to section 3.1. Our exam will be in the week after it, so just after the before the vacation. Okay, Miss?
Is the third lecture or the second?
It's better to be the first lecture, right? Because we're done. Yeah.
Tuesday.
Tuesday it's better because maybe some of you will be traveling on Thursday. Because after Thursday we'll have we have vacations. Some people may be traveling at night or something, so it will be difficult for them to do the exam on the same day.
Next week lectures will be including the exam.
No,
The one is what are the
One and
one.
1 and 2, and the part that we will discuss, I postponed it to the next week. So hopefully in Ramadan we will take only. We will have one of the lecture discussion, one of the lecture which will be exam. We will take only 2 lectures, so it will be easy for you.
Yeah.
And the material, it will not be difficult because this whole thing, some of us know about it. It's something easy, the first part, yes.
Thursday, the real one.
Which Thursday?
Which next Thursday?
I don't know. You will travel at night, you will not travel every morning, miss. As for me, I'm not traveling. I'm staying in UAE, so it's not for me, miss. I'm staying in UAE and I cannot travel on Thursday anyways. Okay. So how did we solve it, miss? X of 0 equals 0, we will get C1 equals 0, right? And x5 over 8 equals 0, we will get C2 equal to 0. So how many solutions did we get? One solution, which is x equal to 0. Okay, so what can we deduce about boundary value problems? It may have no solution, it may have unique solution like this example, and it may have infinite solution like our first example. Whereas if this one, miss, was an initial value problem, how many solutions based? Because continuity, it means that how many solutions? One solution, if initial value problem. If initial value problem, miss, how many solutions will it have? Unique solution. Do you still remember, miss? Miss, if these ones are continuous and it is initial value problem, then how many solutions? One solution only. For boundary value problems, does this theorem hold? It doesn't. Okay, miss? Any questions about initial value problem and boundary value problems? Okay. So let's recall together from so this slide is about linear algebra. What we need from it. Even those that they are taking linear algebra now, we did not explain this part, but some of us know it from calculus 3 or from this. We have something known as determinant. Okay. The determinant that we need to know is determinant 2 by 2 matrix. This one we call a determinant. How does this one work? The purple purple minus the green. We put it, okay? So the purple AD minus BC. So this one, the purple minus the green, main diagonal minus the second. This one we call the determinant, and it will give us a value. Determinant, you wrote it as matrix. Determinant, you put lines. Okay, find the determinant of this one. Please find the determinant of this one. Again, main diagonal minus the second diagonal. Who's the first time seeing this notation, miss? Oh, it's okay.
Minus one.
Okay, how do we do it, miss? 1 times 4 minus 3 times 2. Main diagonal, again, main diagonal, the purple minus the second diagonal, right? Okay, which is 4 plus 6, which is 1? 9. Is it clear?
Yeah.
Okay. This is determinant of 2 by 2. Determinant of 3 by 3, we need to learn it as well. This doesn't mean that you have to do determinant of 3 by 3 in the same way as I do it. Because some instructors, they teach it to you as lines at least once. Do it as you prepare. But for me, I feel that this is the easiest one. Okay? Now, what if we have those who took calculus 3, we talked about it, and those who already finished linear algebra, we know it, right? Okay. Now, determinant of 3 by 3 matrix. We will have here something, here's something, and here's something. And we have also here things, right? We have 3 by 3. Plus, each row in it we have 3, and we have 3 rows. How do we find the determinant? You will put plus, minus, plus as a first step. Okay? Then this one into something, minus this one into something, plus this one into something. The first step, writing plus, minus, plus in this way. Stop writing a little bit less. We need this one to fill this one. How do we fill it? It's for the apple. Cover the column of the apple. Okay, miss? Cover the row of the apple. This one that you are left with, put it here. Okay, miss? Can you put it in? Can you put it? Put the note of finding it, because I will erase in order to find the second one.
You want to people. We need to go to something people.
Engineer algebra, we'll learn determinant in general. All of them the same. Okay, done with this one. Now, what do we need to fill this? We need to fill this part, right? This part is related to the peer. So we will cover the row of the peer, right? And column. What are we left with? The ones that they are not covered, write them. Can we put it as a note? We need now to find, what do we need to find after the pink part? We need to find the blue part that's here. So what should be covered? The cloud, the column of it, and the row of it. This one that we are left with, we will copy it there. Okay, miss? I will give you an example to make sure that we got the idea. We need to find the determinant of this one. So how to start this? Plus, minus, plus, right? Right, miss? 1, 3, 2. So we put blue, the blue is what? 1 into something minus the thing, 3 into something plus the purple into something, right, miss? The first step, are you okay with that? Okay, for the first one, what should we cover, miss? Cover the row. Guys, please look at that. Cover the row and cover the column. What are we left with? Okay, where should we write it? 0, 4, 5, 0. We copy it the same. The second one, what should we cover, miss? For the second one, what should we cover? For the 3, what should we cover, miss? Okay, what are we left with? -1, 4, 2, 0. For the last one, what should we cover, miss? What are we left with? -1, 0, 2, 5. What did we get, miss? We got submatrices. The determinant of 2 by 2 matrix. Do we know how to find each of them? Okay, so let's find each of them, miss. Miss, because this one is from another course, I don't explain it in class. If you face any problem in that later on, you can come to my office, but in class, we do not repeat. Yes? Because this one is not related to our course. Yes, I said that you can use it, this one. But for me, because this one, it helped in 3 by 3, maybe in 4, it doesn't help. So I prefer this one, plus, minus, plus, minus. Okay. Now, what we need to do is to find 0, 4, 5, 0. We need to find the value of it. We need to find also -1, 4, 2, 0. And we need to find -1, 0, 2, 5. Will not look at the board. I will ask some of you to do it. So, yes, good shot, please. Come to the board and do the first one. So this one again, main diagonal minus the second diagonal. Ali will do the second one after the shot. And Smiley will do the third one after I. So the main diagonal, 0 times 0 minus 5 times 4. What will we get? minus 20. Thank you, Dr. Please, Ali.
Multiply with, yeah. Multiply with 1.
Yes, then when we substitute, we
Doctor, for the linear exam, same week as differential.
This is because you should study before, right? We cannot do it differently.
Can you make a nozzle on the network? For the.
For the exam, for everything I will do this. I'm just waiting a little bit because we have other announcements. Okay, then what's the next step? What do we need to do? We need to go back to this one and substitute. So what will we have here? Minus 20, minus 3, minus 8, plus 2, into negative 5. So minus 20 plus 24 is 4, minus 10 is negative 6. Any questions, Miss? Do we have any questions? Now, the only thing that in differential equation, we will do the same steps, but we will have, instead of numbers, we will have functions. Let's say instead of 1, I may have x, instead of 3, I may have ex, and so on. Okay? Any questions so far? Okay. I will write some trigonometric formulas that we may use. So this is probably calculus. Sine square x sine square alpha plus cosine square alpha equal to 1. This one we will use it a lot. This alpha means that it can be anything, x, 2x, or 3x. We may need sine 2x, 2 alpha is equal to sine alpha. And we may use cosine square alpha minus sine square alpha is 1 to cosine. Do we have any questions for Florence? Is it okay to know? Okay. Now, an nth order linear differential equation with a homogeneous. The function, instead of the function after the equal, it should be what? 0. Okay. If the function is not 0, what do we call it? Not homogeneous. For example, this one, what can we consider it? Homogeneous or not? Okay. This one, not homogeneous. We said that first order differential equation, it has how many parameters in it when we are in the general solution? How many parameters should we have? These three method? First order differential equation, how many parameters, how many constants do we have? 1, 2, 2, and so on. So here in general, if we have n, it will be n parameters. So how many parameters? It depends on, we are saying here that if we have two solutions, any linear combination, it will be again solution for the homogeneous differential equation. If you look at this one, y1 and y2 are both solutions for this one. So we can deduce that any linear combination of them is again a solution. Does it make sense, Miss? So if we are saying sine x is a solution and cosine x is a solution, it means that c1 sine x plus c2 cosine x is what? Is a solution again. But here for which type of differential equation we are talking? Homogeneous. It means that it's equal to 0 out. Okay. Now we need to introduce something. We need to get at the very end the fundamental type of solution. So do we still remember the linearly independent? We explained it in linear algebra, right? Now the linearly independent, we were talking about vectors. We said that to be linearly dependent or independent, it depends if we have a relation between them or not. For the functions, to check if it's linearly independent or dependent, we need to find something known as Wronskian. If the Wronskian is equal to 0, then they are dependent. If the Wronskian is not equal to 0, then they are independent. So why do we care about independent solution? Suppose that y equal ex is a solution. Already y equals cex also is a solution. So if I'm giving you y equal ex and you gave me y and y equal 2ex, 3ex, all of them, they are the same one, cex, right? All of them are dependent on each other. If you told me sine x is a solution and cosine x is a solution, these two solutions are not dependent on each other. So this one makes more sense. But if you gave me sine x and 2 sine x, for me it doesn't make sense. Why? Because they are linearly dependent on each other. And our aim is to find all independent solutions. Okay, how do you find the Wronskian mass? The first row, you will put all the functions that you have. The second row, what do you do for it? Derivative. And you keep doing the derivative. When do we know that we can stop? If I have two functions, I will do the first derivative. Did I get 2 rows and 2 columns? Okay, so I stop here. I have 3 functions. The first one, the functions. Then I will do the second one. The first one, how many functions do we have? 3, right? The second one, 3, but now I have 2 rows and 3 columns. How many do I need? 3 rows, so I need to do the derivative again and then stop. If I have 4, how many times should we do the derivative? 3. Yeah, sure. Okay, so to be linearly independent, the Wronskian should be not equal to 0. Wronskian, we write it in this way, Miss W. Let's see, sine x, cosine x. We need to find W of sine x and cosine x. So how many functions do we have? How many functions do we have here?
2.
We put in the first row, Miss. And here, the second one, what do we put? Sine x, it becomes. Cosine x, it becomes. Find the determinant now.
How do you know it?
You have 2, you should reach 2. You have 3, you should reach 3. Okay. What's the determinant, Miss? Sine x. This one is equal to what? Please simplify this.
-1.
Okay, let's do it. Minus sine square x. We can take the minus in common. Sine square x plus sine square x is what? 1 multiplied by negative. It's -1. Is it 0, miss? Is it 0? What can we say about it? Linearly dependent or independent? Linearly independent. Make sure that we understood this, please. Try e power x and try e power x. E power x and 2e power x. E power x and 2e power x. Please try. Two E. So then now it's just we are understanding what's meant by Ranskin and its relation with the dependency and independence. But we did not talk about the fundamental set of solutions. What did we get the Ranskin as? E power x and 2e power x. What did we get it? Where did you get minus? Yes. Again, the first row, the function, the second row, the derivatives, right? The derivatives of the functions that they are given. The Shabbat Riga, 0. Mine also got 0. Who got 0? 0. The others miss? 0. So what does it mean? Linearly dependent or independent? Dependent. Now, why do we need these ones? So we found the Ranskin. If the Ranskin is 0, dependent. If the Ranskin is not 0, independent. What did we say? If we have second order, how many independent solutions should we have? 2. And the general solution will be their linear combination. If we have third order, how many independent should we have? 3. And the general solution, it will be their linear combination. C1 the first plus C2 the second plus C3 the third. So we're saying here, if these ones are n linearly independent solution of the homogeneous linear nth order differential equation, then what do we call them? Fundamental set of solutions. If they are dependent, can we call them fundamental set of solutions? Can we? Why do we call them fundamental? Because these are all the independent solutions. And any solution, it will be combination of the first plus second plus third and so on. Okay, miss? How do we write the solution now? C1 times the first plus C2 times the second and so on. And how many parameters do we have? How many constants should we have? According to the order, yes. If the order is 2, how many should we have? 2 and so on. Miss, please write these ones because they are important. What's meant by fundamental set of solution? now we know an initial value problem. When can we say that it has a unique solution? We know the boundary value problem is to have a unique solution. It can have no solution, infinite solution, or one solution only. We know what's meant by homogeneous. And for the linear differential equation, it means that what's after the equal is 0. And we know the Wronskian, how we find it, its relation to linearly independent. And if they are linearly independent and the same number as the order, what do we call them? Fundamental set of solution. And the general solution will be written in this one. In this form, y equals c1y1 plus c2y2 and so on. In order to understand this slideness, we will give a quick example on it. Any questions before we proceed? Did we finish taking our notes? Let's look at this one. Y the prime plus y equal to 0. Part A, y1 equals sine x, y2 equal to sine x are solutions. These ones are given. We are not asking you to solve. The solution is given. Part A, find Wronskian of sine x and cosine x. We found it, right? Okay. Part B, show that sine x to sine x forms a fundamental set of solution for x. And part C, write the general solution of one. The first one, is it necessary to find it again? Let me see here. Did we find the Wronskian? So we can just so part A, we're done with it, right, miss? What can we deduce from part A, linearly dependent or independent? We got it -1, right? So it's what? Independent. So we got it as -1. It's not 0, then linearly independent. Now part B, they are asking us, show that sine x forms a fundamental set of solutions. How many solutions do we have here? 2. What's the order of this one? 2. From here, are they dependent or independent? We got them. Okay, so we have, they are 2 independent solutions plus the order is 2, so fundamental or not? If the order is 3 and we got 2 independent, can we say that they are fundamental? We should have how many independent? 3. If the order is 100, how many independent should we have to consider it as fundamental? 100. Does it make sense, miss? Johnny, is everything okay? Here, Ahmed and Muayyad, Abdul Aziz. Okay, so this one, can we say, how can we solve it? In part B, sine x are 2 linearly independent solutions for x. This is the first step. What's m is second order linear homogeneous ODE. What can we deduce from both methods? Imply that sin x, so sin x forms fundamental set of solutions for us. Okay, how can we write the general solution now? Let's go back to this one. How do we write the general solution? Y equal y2. And what's y1 and y2? Sin x and cosine x. Perfect. So what's the general solution now? The general solution y equals c1 y1 plus c2 y2, which is c1 sin x plus c2 cosine x. Is it clear? I will go back to it, but because I don't want to forget to add it to you. Any questions? Previously? Question D, find the general solution. Another one. Can you try this one? So here the equation is y double prime minus 9y. I need from you first to prove that these ones are linearly independent, that they form fundamental set of solution, and then find the general solution. Okay, miss? E 3x, and miss, the second one is E minus 3x. Do this one, miss. Miss, hopefully next lecture we will do, as we said, we will do the discussion. And then this part, what's left is, we talked about the homogeneous. I shared with you the file. Please try to do example 6 and example 7. Then after it, we'll talk about the non-homogeneous part. And we will talk also about if we have a solution, how can we find the second solution? Then after this one, after understanding what's meant by fundamental solutions or something, what's the next step? Solve the differential equation. Here we are given the solution and we are working on it. Later on, we will be given the equation and we have to find the solution of it as we did in chapter 2. But the good thing here is that we don't need integration. So the solution is very easy. We just need integration in one part in this section, but in the other sections, we will not need integration anymore. Any questions, Miss? Okay, yes. Happy Ramadan, and I will see you hopefully next Tuesday. Okay? Yes, no, you don't have it. You don't have it. You did not submit anything. You submitted already. You don't have, you can do it alone. You're wishing to submit and we. Okay, you can do it both.
Doctor, how many classes they teach per semester?
Course for section. You mean like how many classes do I answer? This semester I'm teaching more, I'm teaching 5, but usually less.
Thank you.
Is it manageable for you?
It's okay for me. I prefer not to have that much, but it's okay, I can manage. Like I have to get rid of some things related to me. The me part, I should be like sacrificing in order to be rich. But in important cases, I prefer to be.
So that's what you teach you.
It's written. The section 1.3, everything is written. Okay, so check the announcement. If you still face any problem, let me know and we will discuss.
Not a problem.